Good evening. We're gonna get back working on Dashkin. Alright. It's been a few days. Alright, what we're working on is we're working on all this stuff. So right now this is our night sky, which is looking pretty bad. Let's pull up that piece of concept art that we're trying to match. So the piece of art we're trying to match is this. Or at least get close to matching. The issue right now is we want to put these, I guess spectral halo is what Adam was calling it. We want to put that into the game. So, how are we exactly going to do that? Well, the thing is, we've been working on. We kind of analyze what we want this to do. The eye effect, we want a rotation angle for it because it's not, it's not just circular. There's actually like this fall off that goes on it. Yeah, so there's kind of like two directions that go out. So we'll need some sorts. We need concentric circles. We need a number of them, and we need it to be centered at the point of light. So what we have been messing with is our material. I'll have to get back into this. I think it's this test sky material. So yeah, we're looking at the moon. And I shouldn't call this the God's Eye, I should call it spectral halo, because Adam was yelling at me for not using the art terminology for it. Alright. So, what are we trying to do exactly? Well, we've got the light direction dotted with the camera vector. We kind of want a smooth thing. So let's see, I think I kind of want to make sure I have a smooth value between 0 and 1. Well, I guess 1 and 0, and then we can like multiply that out. Because right now this obviously is not the correct thing here. Well, that's kind of crazy. Yeah, math is just kind of breaking down for a lot of this. So let's remove most of it. So if we just do the dot product and multiply by the our color, what are we looking like? Well, it goes from we've got our camera vector dotted with our our light direction. So the camera vector I gotta get back into this. I'm still also just waking up a little bit. So that's going to be less than 0. So we have our light direction, then we have our camera vector, and our camera vector is moving all the time here. The direction from the pixel to the camera. Okay, so this is the direction from the pixel to the camera. So yeah, that's going to... Yeah. So if we have this pixel and we dot it with this light direction, this is from the camera to the pixel, dot that, and we get... I guess, is it a normalized thing? Alright, but it's not from 0 to 1. That's for definitely for sure. Does it need to be normalized? Let's try normalizing it and see if that actually does anything for our equation. Doesn't look like it. I guess it really doesn't... Does it go from 0 to 1? I guess that's the... Let's see, if we do a clamp. Does anything change? No, it just goes to 0. Well, if it goes from 0 to 1, I can't really tell if it goes smoothly, though. That's kind of the problem. So I'd like to see the math, you know, like see a number on each one of these. Let's see if we clamp it at like 0.5. Clamp it at 0.1. That's what 0.1 looks like. 0.5. 1. We clamp it at 2. Or 10. Looks like it might actually go from 0 to 1 smoothly. Alright, and we had this multiplied by 360. And we're clamping at 0 to 360. Hello, Kinto456. I'm back after a couple days. back to working on stuff. When I'm trying to work on this kind of spectral halo sort of thing that's going on with the getting these rings. Now there's a couple ways I could do that. I could actually have like a textured thing for it. Or we could try to do it with math. And I'm trying to think which one would be better. So I think I had the right idea here, which was to multiply this thing by 360. And then what we would do then is I want to from 0 to 1. Maybe I should multiply by pi or whatever. Oh, that's interesting. So we have an actual, like, multiplier here, which you can do with... Oh, okay, so these math functions are actually kind of neat, aren't they? Because you can do a multiply, and then you can kind of throw a multiplier as an input to this math function. Well, it's interesting that it has a multiplier on it, but it doesn't let you actually input it, so we need like a constant in here. And we'll just take the cosine of this. It should go from what? It should start at 0, which should be 1, right? Like, isn't cosine like the x-coordinate? So I guess it starts at 1 though. So alright, so that's basically just going to go from 0 to 1 and then all that. So if we do this, it's 2 pi, and we need to multiply it, but we kind of want another multiply here, I think. Where we multiply, like, that's how many circles we actually have. That's 360 circles. But the problem is we're getting this, the length is changing. Is it that our dot product doesn't change uniformly? Alright, let's just see if we can convert from the dot product to the angle. I mean, that's kind of the effect that we're looking for. Alright, so if we have the dot product, it's going to be one vector projected onto the other, but I'm looking at like so that goes from 0 and continues to get larger. And I guess if I clamped it from, maybe I should multiply it or divide it. Divided by pi. It looks like it's smoothly. I mean, that's definitely kind of the smoothness that I'm looking for. Because if we look at this in the actual world, we're looking at a, it's a very small amount of surface area we're actually looking at. So we just have a very small halo that's really far out but doesn't end. So what exactly do we need to do? I guess we want to multiply this by the cosine. We want to take the cosine of this value. Yeah, we'll use cosine and arc cosine. Yeah, that sounds like a really great idea. Well, it should give us the angle, and then we're basically taking the inverse of that. So if we multiply this thing out by like 2, multiply it by 360. Is that uniform? It looks uniform to me. That's what we're going for, is kind of these universal sized bands, that are equally sized bands, I mean, for our color. And that's going from 0 to -1. So if we wanted to, do even more, we're going to want to clamp that value. That way it doesn't have the inverse, it doesn't take everything to black. It'll just look like that. I'm gonna go ahead and take a screenshot of this. And see if the pixels are actually lining up properly. Do a little bit of cutting. So let's see. This is not the same distance. There is a it's again, there's a little bit of a difference in the size, which actually is what this looks like as well. This has different, like this is not just a nice little crazy difference. Alright. So we need to have this not get quite so... Let's see. If we wanted this even closer. No, this needs to be real close. Still needs to be closer. Alright, so now what we need to do is make it not so strong, and also we need, I mean, this is pretty much what we had before. So I mean, was it exactly the same damn thing as we had before? Just go back in time. It doesn't look like it, because we had 2048 right here. Yeah, no, it's definitely not the same math equation. Alright. Well, let's just reload from disk for that asset, because I saved it and I didn't save it after that, so I can undo and redo by throwing it all in the trash. Alright, so this is what we had. And yeah, we're getting much more concentric rings like what we're looking for, which is good. Alright, so now let's make them less hard. Like, we want them... It looks like the fall off is too much. Like, we need... something to lessen the from 0 to 1 right there. Kind of make it more not so harsh. So let's see if we go into our sky test content. Let me go to our test material. What in our math here can we do to make it less harsh, to more make it, blend? So let's see. I think what would make it blend better, like this is basically right here, the how many rings. Yeah, clamp between 0 and 1, we want that. This is, we're taking the cosine of this number, and this is like our rings right here. If we want to fade those rings out, so we've already taken the cosine. If we multiplied it by itself right here, the negative values would become positive, and we don't really want that. So we actually want to clamp it between 0 and 1 first, and then we want to maybe multiply it by itself. So we multiplied it by itself. No, we want to do the opposite of multiplying it by itself. It's kind of, we want to make it so it gets larger faster. How do we do that? We could like right now the kind of the space we're working with is from when it goes from 0 to 1 over time. It kind of starts at it starts at 1 and then it goes off like this. It's kind of our value. So turn it on its head, it kind of goes like this. And the issue is we want to take this value and we want to turn it into a linear value. So if we multiplied it by itself, it would actually make it crash into the floor that much faster. If we divided it by itself, it would just be 1. And if we took the tangent or something, right, that's the slope of the line at that point. It's a mathematical operation to do this. Is it taking the log of this value? Is that what it is? The number that multiplies by itself to get this number? Because we would get, like, if we were here, we would get a larger number. Like, this number times itself would equal that. So, yeah, I think we need the log. What the hell? That's kind of nuts. Can we even do that? Logarithm. So we need to take the log of this value. Let's see what log 2. The logarithm expression takes two inputs, computes x logarithm base 2, and outputs the result. In other words, the number of times you should get 2 multiplied by itself to find x. The logarithm computation happens per channel. Both inputs must have the same values. Okay, so we don't have log 2, we just have log 10. Is there a log 10? Yeah, we just don't have these mathematical... We don't have this math here, so we need something else to change this into what we want it. So let's think. It's looking like this. So if we took the sine, I mean, we could, like, the sine value of this thing is going to be like that, pretty sure. So if we, like, added those values together or something, if we multiplied them together, like, you know, this is going to be, you know, like 0.1 times, you know, 0.3 or something. Maybe we could average them, right? And we would get this linear thing. So we would take, like, the sine and cosine, add them together, and divide. Alright, well, let's see what we got with that then. So if this is the cosine, then what's the sine going to look like on the same? Of that same value. We'll clamp it as well. So the cosine looks like the sine looks like this. Why are they so different? Yeah, that's interesting. Why are they so different? Sine and cosine should be, as far as I understand, kind of opposites of each other. Like one is the x-coordinate, one is the y-coordinate. Is there some difference in how these things are? Yeah, the output value will cycle back and forth between -1 and 1. And this one, the output will cycle back between -1 and 1. The difference between this and the output of the cosine is the output waveform is offset half the period. Yeah, so it's like, it should be just an offset. I mean, if we take the clamps off, you know, that's sine, and that's cosine. Why is it so different? Is there some sort of difference in inputs? Oh, okay, here it is. The period right here is 30. We want to change, the periods need to be the same. No wonder I was like, why is this math all sorts of screwed up? Now the question is, why doesn't this, which is our actual material, look like what's actually being applied here? Is something broken? Let's restart the editor and see if something didn't save properly. Yeah, this period did not save properly on this thing. Because I changed the period to 1 here, save it, and it didn't save. Well, let's make a new cosine node. And it saved that time. Man, what a pain in the ass. So, what we're going to do is we need to do that clamp again between 0 and 1. There we are. And let's get our sine in here. So yeah, saving problems with materials, that's just unfortunate. I wish there was something else in there that didn't have all those problems with it. Yeah, so this is what I would expect, is if I just do these two like that, they're offset by an amount. So the sine is, the output wave set is offset half the period. So what we want to do is we want to add half the period to these guys. So it's going to be, what? If the period is 1, then we need to add 0.5 to this sine to get the same value as our cosine. So let's just add 0.5 to it and match it up. Yeah, and it looks like that's definitely filling in our rings with the proper amounts. Not bad. So what we're going to do is we'll try averaging those things together with my amazing drawing that looks like something not very suitable for Twitch. So we're just going to add these two together and then divide by 2. Is there an average? No. So add these two together, divide by 2, and see what that looks like. Well, it's definitely closer looking. It may be that it's not offset enough. Maybe we need to add another like 1.5. The thing is, it's going to 0 or something like that. So if you add them together, we get this sort of thing. Which really isn't doing what we want. It just... It's not fading out smoothly still. Do we just need to take, instead of the cosine or something like that, we need to take the tangent? That is ridiculous. It goes to infinity. It goes from 0 to infinity. With horrible math. No, it's not the tangent. And if we clamp the two values, it doesn't really work very well. So let's see, what if we add 1.5? 0. 0.5. And the period is supposed to be 1, so I mean it's... shouldn't matter. So it's like 0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. I don't see any real difference. Looks like at a difference of 0.25 is where they both match up. Is that correct? Interesting. Alright, so and max C mode clamp. Wish I could overlay them, maybe put them as different colors. So if I just change this color to something like red, maybe I can see this a little bit better. And I'll change this one to blue. And I'll just have this multiplied by blue, and then we'll add together this thing. So they're perfectly lined up. Alright, so the blue is the amount that's being added by the sign. Purple is them doing that, and this is all the X coming through. So this one goes like that. So we're trying to draw our math. So if we added those together and divided by 2, you would expect it to be a smooth band right there, and that's just when they're together. Alright, so if we just take our normal color, our red here, we multiply it by this color here. Then we just use this output. I mean, theoretically that works, but the issue is I see this is we've got this kind of inner band here, which is not super great. It's like they're not perfectly offset. Seven, 8. that's just 1. That's 0, and that's 1. So that's 0.8, 0.7, 0.6. I mean, that's when they're completely in phase. I mean, maybe if we didn't clamp them. Alright, that's starting to look a little bit more like what we're looking for. Look at all that craziness. Yeah, that's starting to look a lot more like those clouds that we want. So if this was just a 1, 1, 1, 1, right? So how many rings do we need here? A lot less than that. So maybe something along those lines. And then we want some sort of period added to it. Now we're going to want to add after the multiply. I want that to start right in the middle there. Alright, so 1.2, but 1.3, 1.4 maybe. One 1.5 or 1.6. So I'm not sure. Let's see. You know, at some point here, it might just be a better idea to throw a texture up there of the actual rings, because the math is kind of, I mean, we can mess with the math equations all we want, but it's still kind of meh. You know, like it's still just math as opposed to art stuff. We might actually get a better effect out of just, you know, grabbing something like this and just throwing it in there and seeing how that works, right? So let me see, if I was going to grab an actual really crappy sprite of this, what would it look like? Nah, I don't have a good sprite of that. I'm not really sure the right way to make it. I mean, it would just be a couple rings with some blurs on it. Would that be enough for it? If we just made